Good evening. My name is Javier Estrada, and what I'm going to talk about tonight is about a conversion story, which is not about meeting my C maker, right? Or changing faith. It's simply about visiting or revisiting, if you will, the conversion routines or conversion functions that we have now in C++ 17, and they are in the CppCon header file. So we have a couple of conversion functions. The first one is the std from chars, which allows us to convert to a specific type, right, from a string, whether it is a C-style string or, as we'll see, we can also use other things. The other one is to chars, which also allows us to get a string of characters, or either a C-style string or something else. We will see how we can improve that. The nice thing about these functions is that they are low-level conversion, character conversion functions. They are different than the std to string in the sense that they are locale independent, unlike toString. They are non-allocating, and this is a little bit tricky because you have to do the allocation, basically, right? Non-throwing, because you do the allocation, so you don't have to be worried about a bad alloc. And they support integral types in char, except Boolean. And that's important. I will make a comment at the end about conversion to bool. Support floating types, and they are, as I mentioned, they are in the header file CppCon. There is going to be a talk tomorrow, floating point CppCon, from Stefan Lavavech, STL from Microsoft. And you can attend. He's going to have great material as promised in the summary of the session. So if we look at std from chars, you can see in red that every overloaded function has a first and a last parameter, right? And then you see the C below, and that C below in cppreference.com is all of the types that are supported. You can also see that it supports the three different floating point types, float, doubles, and long double. And similarly, into chars, you can see that it's the same pattern. You have a first and a last parameters and the same type of support, right? So the usage is, there can be a little bit of change in the usage, but what you can do is basically you can have, let's say, a C-style array, and then you pass it. In that case, I'm using if with initialization and then testing. You have to test against error C, right? That's your test. If that's not true, then conversion failed and you have to do something about it, right? So that's a typical usage. Can we make this better, right? And obviously we can. And the reason is that there's one extra pointer there that we don't need, right? And being a little bit lazy, let's say how we can eliminate that extra pointer. So what if instead of calling it in the way that I showed you before, we eliminated that extra parameter, and we are just passing, right, that string as itself. We are not counting. We don't know how many characters it has, right? Or we could also call to chars in the same way, right? We're only passing one parameter. Continue. So in the same manner, right, you can also, or we can also use an array.
Stop for a moment.
Go ahead.
I realize what's going on. Okay, well, we'll do it by ear. That's going to be better, isn't it? So if you would like Javier to complete his talk, then please show that by your applause now. I think that was definitely sufficient, so I'm going to hand the mic back to Javier to complete his talk now.
Thank you. All right, so let's make this faster then. So in that slide, we're using STD array, or we're using a string, we're using a string view, we're using a vector. Pretty much anything that has contiguous storage, you can use. So I'm showing another example for 2 chars. And what do we have? So this is a little utility header file that simplifies the usage model, eliminates the last parameter in all function calls. You don't need to know how long a C string is, just pass the pointer, right? And it extends to containers that provide a data member, contiguous storage, anything that is there, right? And it also preserves, this is important, preserves the semantics so there are no surprises. The reason is that to chars, when you get back the pointer, it's not null terminated, which can be a surprise. So there are a couple of helpers. The first one is a template that enables if integral, and the other one for floating types. So that is the template function that takes integers. So it returns the from chars result, and it takes an array by reference, which helps us so that it doesn't decay into a pointer. And then you see the one at the bottom, also the same thing, but for floating types, right? Similarly, for 2 chars, it's very similar. Pretty much all of these functions are one-liners. It's just wrappers over 2 chars and from chars. And you can see for containers, it's using data and data plus the size, right? And the same thing for the floating. And you can see 2 chars, which is bigger because it's more overloads. So those are the function templates for those. So pretty much what I'm doing there in these ones, and it can be done in all of them, right, is checking that the type is a character and validation for Boolean, which I will mention in a second. So Boolean is a type that is not supposed to be accepted. There is a compiler, in particular the Microsoft Visual C++ compiler that is accepting Boolean right now. I got in touch with Stefan, and he actually had noticed something similar and had exchanged some information. He got me in touch with Jens Moore, and Jens, he entered, a bug. So my assumption is that it's going to be addressed. So it's LWG issue 3266 if you're interested. There are a couple of improvements you can do. One of them is that you can pre-allocate the memory and pass, let's say, a string with one element only, and then just loop until you calculate how much memory you need, right, and just call these functions, right? I thought about putting it inside the template, but then it changes the semantics, and this could very well just be used just as an extension, right, to the current char count. And I think that's all I got. Thank you very much, and good evening.